So these are the industrial versions of 3D printing today. This is kind of where we sit with a lot of the technologies. So stereolithography, for those of you who aren't aware, that's a laser-based system. The laser shines into a photopolymer, a liquid photopolymer, and turns it into a solid. Again, that was the first technology back in 1986. EOS is probably the leader in selective laser sintering. 3D Systems also offers SLS, but EOS is really taking a chunk of their market with their system, and that's a powder bed system. So it's a laser shining into a powder bed of nylon and fusing and sintering the material. Then we have FDM. Again, it's the filament system, so your weed whacker type of line. In the industrial levels, we can do high-end materials, so we're doing polycarbonates, we're doing Ultems, nylons, PCABS. So we can do a lot more things with the industrial grade systems than you can do with the consumer level. And then down at the bottom is the PolyJet technology. So it wasn't until 2004 that RepRap came on the scene, replicating a rapid prototype machine. That's what RepRap stands for. And the whole idea behind this was that these guys were in the UK, they developed a filament system, and the whole premise behind it was that they create parts off of this that I would give to you to make your machine, and then you would make parts off of it and give it to your friend, and then he can make his machine. And that was the whole idea behind this system. But what this system eventually led into was the invasion of the consumer level 3D printers, the fused filament fabrication, which is FFF. And that's what all the consumer levels filament systems are. So the filament printers came out in the mid-2000s and gave everybody a taste for 3D printing. There's also some other smaller end SLA type consumer printers that are available, laser-based and DLP-based. And then shortly after the consumer system explosion, we ran into the metal explosion. So metal 3D printing became really popular shortly after. There's a lot of different technologies out there for metal 3D printing. And I think that the metal really hit the scene with the idea that they were going to, again, cater towards the injection molding world and allow people to make tooling inserts quickly for injection molding. And the real metal explosion happened when GE got involved with metal printing. And GE launched this part here. I don't know if anybody has ever seen this or heard the story, but this is the fuel nozzle for the LEAP engine. This fuel nozzle was made up of approximately 20 individual components at one point. So GE challenged their engineers to see what we can do to get this down. How can we consolidate the part count? How can we make it better? How can we make it more efficient? They took the 21 components, combined it into one, and this one single part was 25% lighter in weight. It was 5 times stronger, and the combination of those two things led to a huge savings in fuel. I think it was $3 million per aircraft in fuel savings. So GE says we have to make 4,000 of these, and each engine takes 19 of them. So that was a big, big deal for the metal world. The other industry that really benefited from metal 3D printing was the medical industry. Medical industry is huge with metal right now, creating titanium implants. And it's really been great for the medical world, specifically because of these lattice structures that you can create, and the granular structure on the parts actually helps promote bone growth. Even pre-op planning, things like that. You can do patient-specific needs. So now you can do some scanning of you, CT scanning. They can create a knee to fit you specifically. So patient-specific is big industry. And again, the metal world is really taking advantage of that.